So, here's our warm-up. Cosine of 11 pi over 12. Okay. I don't care how you do it. Okay. But if on a test or a quiz we say you need to do it a specific way, then you need to do it that specific way. Okay? But for right now, wide open. Go for it. Depending upon the way you do it is going to depend upon how your answer is going to look. So if you did it with difference in sums, then your answer here is going to be negative square root of 2 minus the square root of 6 all over 4. If you did it with half angles, then it's going to be negative 1/2 times the square root of 2 plus the square root of 3. What was that? Because it's 11 pi over 6 divided by 2.
Oh.
So it depends on which formula, which identity you use. Okay? Good? Questions on it? All right. Here we go. Let's jump back into law of sines. Okay? Before we jump into law of sines, I want to draw attention back to what we talked about yesterday. So yesterday we talked about, if you had me yesterday, this should be starred, bolded, highlighted, all that fun stuff in your notes because it was important. Okay? So yesterday, if we're dealing with the angle side-side case, and the opposite side is greater than the adjacent side, how many triangles get formed?
One.
Always one, right? Yep. So this is an always one triangle case. Okay? If the adjacent side is bigger than the opposite side, then the first thing that you've got to do is you've got to check your height. And remember from yesterday that your height was the adjacent side times the sine of the given angle. And then that gave you 3 possibilities. Possibility number 1 is h is equal to the opposite side. And then you get one right triangle. Possibility exists that h could be bigger than the opposite side. Then you get no triangles. Yep. And the possibility exists that h could be smaller than the opposite side, and then you get 2 triangles. Okay. If you have a 2-triangle ambiguous case, then, and everybody should write this down, and if you were in my class, you wrote this down yesterday, hopefully, then your step number 2 is you find angle B sub 1. So you find whatever it is that you can find using the law of sines. Then you find angle C sub 1 using triangle sum theorem and side C sub 1 using law of sines. Okay? Then, angle B sub 2 is going to be 180 degrees minus angle B sub 1. So whatever angle that you found first with the law of sines, you find its supplement, that is your second triangle's angle, B sub 2. Then again, you're going to find, oops, I forgot to find. You're going to find angle C sub 2, triangle sum theorem on your new triangle, and side C sub 2 using law of sines on that one. Okay? Those are the steps that you've got to do in order to do it. Let's do it now. Let's go back here and let's do that. Okay? So, we've got angle B here is 32 degrees. We've got side B is 5, and we've got side A is 7. MIN, we called this mental math yesterday. MIN, an angle side case. Yep, for sure I'm in it. I got one angle and two sides. That's an angle side case. As long as it's not, if I had the other, if the angle was in between it, the included angle, then not, but it is. This chair is kind of in the way. Okay? All right. Step number 2 then. Where am I at in terms of my opposite and my adjacent? Which one's bigger? My adjacent is bigger. So what does that mean? One triangle or check H? That's a check H. Okay? So then H is going to equal 7 times the sine of 32 degrees. The adjacent side, which is 7, times the sine of 32 degrees. Anybody? .709-ish. Okay. How does that compare to my opposite side? It's less, so what does that mean? How many triangles? 2 triangles. Okay. So, in triangle number 1, then I can say that the sine of 32 degrees divided by 5 is equal to what? What is the sine of 32 degrees divided by 5 equal to? Sine A over 7? Yes? Okay. inverse sine of 7. Oops. That breaks. Escape. 7 sines of 32 degrees all over 5. And I want to store that as my A. I get here 47.8924 degrees. Yes? Okay. That is angle A sub 1. Is 47.892 degrees. Love it. Angle C sub 1 is going to be 180 degrees minus 32 degrees minus that. Minus 40, not 42, 32. So that gives me angle C sub 1 is yes? Then we got to find side C sub 1. Sine of 32 degrees all over 5 is the sine of angle C all over side C. So we got 5 times the sine of C degrees divided by the sine of 32 degrees gets me, I get here 9.28896. Oops, scroll back up. Questions on those 3? Agree with me on those 3. Yes? Okay. Now we got to go find the second triangle. So first off, we found angle A first. So I'm going to find angle A sub 2 first. And that's going to be 180 degrees minus 47.8924 degrees. So that's 180 minus, I've got it stored as angle A. That's going to give me 132.10759 degrees. Then we need to find angle C sub 2. That's going to be 180 minus 32 minus 132.10759 degrees. Minus 32 minus my new A gets me 15.8924. So the angle C sub 2. Then we have to find side C sub 2. Now, here's the nice thing about side C sub 2. All of this math that you did, provided you wrote it down, okay, which you should be writing it down if you want to get full credit, all of this math you did is going to be the same. The only thing that's going to change here is angle C sub 2. So side C sub 2 is going to equal 5 times the sine of my new angle C sub 2 divided by the sine of 32 degrees. And that gives me 2.58371. And there, ladies and gentlemen, are your two different triangles. Yes, sir.
So I understand where you get the second angles for the second triangle from.
Yep.
And then 180 minus the angle. But finding the sides of the second triangle, you're still using the sides from the first triangle, right?
No. Well, yeah, I mean, yes, you're still using the sides from the first, from what was given, but what's given is the same in both triangles. So this angle, this setup is the same in both triangles.
So the second triangle has 7 and 5 as sides,
Mhm.
same length, right?
Mhm.
So if you were to draw the second triangle, it almost be like a mirrored version of it, or
One of them will look like that, and one of them look like this one's a little goofy because they're both obtuse, so they look like that
okay.
because both of them have an obtuse angle in it.
Okay. And that equation that you just did, the pi sine times square root times the sine divided by, that's how you find the side length, right?
The missing side length.
Yes.
Yes, provided you do all this pink work first, you can go right to it. If you don't do all of this pink work, then you got to do all of that work over again.
Okay, so if parallel towards the first triangle that you operate at.
Mm-hmm. Okay. Good. Try that one. How many triangles? One? Should only be one triangle. Okay. It is an angle side-side case. Yes? Okay. But the opposite is bigger than the adjacent, so that is always only one triangle. Okay. So you should get here then, angle C is 112.669 degrees. Angle B is 27.331 degrees. And side C is 30.146. Questions, comments, concerns, clarifications? Three decimal places, yeah. Mm-hmm. Go for it. I still don't know why triangle is spelled so goofy. Must be the font. Yes, angle side case. Yes, angle side case. Opposite is bigger. So that means what? Got to check the height. Okay. Height is 10. Just a little bit more than 10. So that means that the opposite is longer. That means that there are two triangles. Okay. So here is first triangle and second triangle. And the angles that you should get. And side that you should get. Questions, comments, concerns, clarifications? It happens. Means you gotta do more of them so you get faster at it. Always the first one that you find. Because you can only, using law of sines, the first thing that you gotta do is you gotta find that second angle of the triangle. And so it's that angle that you find. Okay? Clear everything off with the exception of you will need your formula sheet.